Hi, everybody. Thanks for coming. Special shout out to Boost VC for hosting this event. The space is amazing. Balaji is planning, well, first of all, let me introduce Balaji Srinivasan, CEO of 21. Thanks for coming out. You can give like a round of applause, maybe. Yeah, thanks again, Boost. Balaji is going to go through a presentation, and then we're going to do a kind of quick Q&A between him and I, and then some questions from the audience, and that'll be it. Thanks again.
Cool. All right. How's that working? Okay, good. Okay, so I've got a quick start over here for people who just want to just start programming. But you can just install our software like this, get an account over here, and then read the documentation there. And I know there'll be people who complain about piping it to the shell, but if you know enough to know that that's bad, you can pipe it to less. And frankly, it's basically the same as installing any software. Okay, so let me, this is a super quick start. I want to give a little bit of a reprise of kind of what we've done technologically and some of our motivation and some of the apps that you can build. And we'll be offering $1,000 bounties for those apps. So if you want to get on those, then might be fun. So basically, I'm going to talk today about this concept called the machine payable web. We posted a blog post on it last week. I gave a big chunk of this talk at CoinDesk Consensus. Who here is familiar with kind of the machine payable web concepts? Just raise your hand. Okay, so about half the audience. So I'll go through this relatively quickly, and just to get everybody level set, and then we can go through the fireside chat, and I'll stay for a while to answer questions and stuff. So basic concept behind this thing we call the machine payable web is it's a way to essentially earn Bitcoin on every HTTP request, to actually have servers that consume Bitcoin and then return a result, whether it's data or something else. And here's my bio for what it's worth. Patrick already introduced me, but a partner at Andreessen Horowitz, founder of 21. Before that, I founded a company called Council, which Peter Thiel and Founders Fund funded, raised more than $100 million for that. Should go public sometime. And finally, I taught computer science and stats at Stanford. There's going to be a Bitcoin MOOC also coming out soon, so you can sign up for that at bitcoin.stanford.edu. Great domain name. We squatted all of those years ago. It's awesome. All right, so let me motivate kind of what we're talking about. We think of this as the machine payable web as potentially a third web. I know that sounds maybe important, but let me try to motivate that. So first we had the World Wide Web, right? We had a web of documents, and the links between nodes were hyperlinks, right? And then we had the social web. In the social web, you've got individuals as the nodes, and the links between nodes are friend relationships or their likes, their pokes, their tweets, their all the stuff that we know and love, right? And we think that there's going to be a third web, a web of machines where the links between nodes are payments between machines. And this is something which really has only become possible with digital currency, because with digital currency, a machine can be said to actually possess money, because the presence of a private key for a Bitcoin wallet or an Ethereum wallet on that machine is like a bearer instrument. It's like cash, right? As opposed to, say, an API key for a PayPal account that can be shut off distal to the machine. A bearer instrument can't be. So this is this concept of machine payable web, basically a network of machines which are paying each other Bitcoin or a digital currency more generally. And the question, though, is why, right? Why would we want a machine payable web? Why would that be interesting? And one answer is because paywalls are actually much worse than you might think. Just to recapitulate the idea of a paywall, this is one of the two major ways we pay for what I call human-consumed content, right? So what is human-consumed content? Like a web page where you're just viewing news, right? And so let's say you want news on interest rates, right? There's two ways that you pay for that right now, or two major ways. The first way is you go to the Wall Street Journal, you look for an article on interest rates, and you get a paywall, okay? And this is something where you have to sign up, and there's some friction to that, right? Conversely, you can go to Google, you can search for interest rates, and you see a bunch of ads, and then your information is below, right? So there's no sign up, it's lower friction, and once in a while you will get distracted and you'll click on one of these ads and Google will make some money, right? Okay. So this works if the consumer of this is a human, that is, you're reading the content. A human is the consumer, right? But if a machine is the consumer, like is the case for an API, there's only one choice. There's only a paywall. So if you go to Amazon Web Services, or you go to Twilio, or you go to any major API, you have to go through a sign-up process, and in fact, you take that for granted, right? You go and get your access key, you get your secret key, and so on. You create an AWS account. There's no equivalent where your machine can just go and effectively give a micropayment to Amazon without a sign-up process for accessing the API. And there's sort of a fundamental reason for that. But let's kind of look at why that's bad. Basically, if you think about what the web would be like if every single time you clicked a link, you hit a paywall, you'd realize you just click a lot fewer links, right? If you just visualize every single time you click a link, there's a new sign-up page. Well, what that means is the web would be more like television, right? Where you'd have just a few channels that you would amortize the cost of a sign-up, and everything would aggregate behind them. Rather than the long tail of links which are in your history that you click every day, right? It'd just be a totally different experience because of the fixed cost of basically signing up for each new website. So this is, this dystopian possibility, and this is what we have. But with APIs, it's actually, dystopian. Like we have that's our dystopian, not possibility, but reality, where every API requires its own sign-up. And you've got your Amazon API and your Twilio API, and you've got your, Clearbit API and this API and that API. But what you can't easily do is do fine-grained calls between them. There's nothing like that's equivalent of a link, nothing that's like a really lightweight way to call out to an API without a full sign-up process with API keys. Obviously you can use a free API, but that's not a sustainable thing. That's actually why Twitter, for example, eventually deprecated a lot of its API features because it was serving 15 billion API calls a day, but it wasn't making any money, right? So the workarounds for this are either you give it away for free and then you try and subsidize in other ways, or you put up a paywall and then you're losing, a lot of customers, right? So the reason that the ad model works for humans, human consumed content, is that you have the option of a paywall over here where some fraction of the time people, when they're getting the content, they pay and most people bail. Or you can have 100% of people paying 1% of the time with their attention. That doesn't work though for machine consumed content because while you can set up a paywall and a sign-up process so a machine can consume an API, a machine will never get distracted by an ad, right? So this over here is like the fundamental reason why the ad model doesn't work for Amazon Web Services, right? The script that you write when you load in the API keys is always just going to go unerringly towards its target. It's never going to get distracted one out of 100, one out of 1,000 times and click on an ad, right? So you need a fundamentally new monetization model if you want to have fine-grained remote API calls, right? You're going to need something where a machine can make a micropayment to another machine. So for a machine web, we need a machine currency. And that's why I put this up there. We need Bitcoin or something very much like it, right? Now, when I gave this talk, it was at the consensus conference where there's a lot of guys who were talking about blockchain and whatnot. And for Bitcoin here, you can really substitute a decentralized digital currency. It just needs to be something where there's a bearer instrument that you can actually have on a machine, right? And over time, we may actually support other digital currencies, but right now, Bitcoin has the best infrastructure, so we are definitely supporting that. So that's why we built 21, basically to turn Bitcoin and digital currency into this currency of a machine payable web, where machines can pay other machines back and forth autonomously and do that much faster than any human could, right? Once you can do this, there's interesting second and third order effects that happen. Machines can set up prices. Machines can automatically choose between the best prices. All that intelligent agent stuff that people wanted in the late 90s is actually possible. To be a little more precise, what does the 21 software do? It basically does three things, right? First, it's a quick way to get Bitcoin on any device, and we've got a variety of methods to support that. Second, it's a way to add Bitcoin to any app. So you can put one line of code in any Python app, which either Flask or Django. We'll have other ones coming soon that support micropayments in this fashion, right? So 5,000 Satoshis per invocation of this function. And the third thing 21 does is it allows you to earn Bitcoin in every HTTP request. And the way this happens is you take this machine payable app that you just built over here, you plug it into our machine marketplace, and now other people can discover it and buy and sell into that endpoint. Let's go through these things in order, and then give a little bit of the philosophy of why we're doing this and take some questions. So first, what do we mean by get Bitcoin on any device? So I think 21 is probably the fastest way to get started with Bitcoin without a bank account or credit card, right? And the reason for that is, so first you can just easily, install 21 like this, right? So you install it and it'll, give you some feedback, and you can see whether it's successfully installed. They'll work on a Mac, they'll work on most Linux distributions. If there's one that you haven't seen, let us know. We've also got a Docker image, so you can probably run this, in a VM on Windows. We'll have native Windows support coming soon. So this is the way you install it. And once you've installed it, we've got 5 different ways that you can get Bitcoin, right? So the first way is, if you've got a Bitcoin computer, 21 Bitcoin computer, you can run 21 mine and you will mine some Bitcoin, okay? The second way that you can get Bitcoin is if you do have a credit card or bank account, you can go and integrate your Coinbase account and you can just buy Bitcoin. And all this stuff can be done not just at the command line, but programmatically with like an import call, okay? The third way you can get it is if you have a social network account and you sign up to 21, you don't need a bank account, you don't need a credit card. You just use a social network account to rate limit it so that there's an abuse. But you can just request Bitcoin from our faucet, right? And this is fun because you can just do this on any machine, get a little bit, just start messing around that, runs your first Bitcoin Payable APIs. But the fourth and the fifth are in some ways kind of the most novel. So the fourth way to get Bitcoin on any device is by using 21earn. So this command is in early access now, so just email us at support@21.co if you want access. But basically what this is micro tasks, micro jobs, right? So in this example, we're inviting people, and we are basically paying out if those emails are institutional emails. We don't pay for Gmail emails, and we don't pay for invalid ones or for guys who are already in the database. But if you give an institutional email and it's not in our database and the person hasn't set up an account yet, that's valuable to us. You just did some work. Okay, we'll give you some money, right? Now that's actually a small thing, but it's a kind of a big thing in the sense that it's never been possible to have an instant job on the internet before. There's companies that will give you coupons for inviting people, like an Uber will give you discounts if you get people to sign up for it. But giving out cash on the internet, digital cash, hasn't really been possible, right? Lots and lots of websites will take your credit card and you can pay them, but very few websites will pay you, right? It's actually, there's a non-trivial barrier to doing that, especially small amounts of money for just clicking on things. And so this is really the foundation of something where in 5 years, 10 years, just like you can go to a forum and instantly join a community, you can go to a page and just start clicking a lever, pulling a lever, and it's an instant job. You're doing work and getting money, right? So this is the foundation of that, right? The fifth way to get Bitcoin is by basically running this command 21sell. So while earn was basically putting in labor, like pulling a lever or clicking a button and getting some money, this is really putting in capital, putting capital to work in the sense of your machine, right? So while you're asleep, your machine services requests over here for Bitcoin. It runs, for example, in this case, a ping service, and services say 14 requests over 2 hours for 87 cents, right? Now, it might not seem like a lot, but if you're sleeping and your machine is making you like 50 cents or $1 a day, that is actually an enormous amount by internet monetization standards. Basically, just to put this in perspective, Facebook makes about $1 a year, for a person, rather $1 a month for a person in the developing world, and about $10 a month for somebody in the developed world. And so if you're talking about like $1 a day, that's like a huge amount of money for internet monetization. It basically make you a super valuable subject. This can be done just by sleeping and letting your machine service requests on your behalf. Now, importantly, these three methods, the faucet, the earn, and the sell, don't require any hardware. They don't require any bank account. They don't require any credit card. So the kinds of things that in the relatively near future you can build into phones, you can build into Linux distributions, you can build into applications of different kinds to allow people to make money passively just over the internet, right? Okay, so that's one. Let's get Bitcoin on any device, all right? So the second thing that 21 lets you do is it lets you add Bitcoin to any app, right? And by this what I mean is you can take any, in this case Flask app or Django app, and we'll have more soon. Here's just a standard vanilla Flask app. It's like a hello world, hello Bitcoin, right? You go to /hello and you get this message back, right? And now we add in micropayments, right? So after the import step over here, we just add one line over here that says every time you go to this page, or go to this URL rather, you're paying 5,000 Satoshis for you to access it, right? Now 5,000 Satoshis, okay, that's cool, it's a constant. What gets much more interesting is if you pass in a function. Okay, so now you pass in a function which takes an HTTP request and returns an arbitrary dynamic price. Now that's actually like, pretty big deal, right? Because there's several things you can do with that, right? So first is, if you want to, you can make the price oscillate, with the time of day, right? You can give a lower price if the person is authenticated as your friend, a friends and families discount, right? You can give a higher price if you've got a bunch of different machines that are all hitting you at the same time. You can give surge pricing for APIs, okay? You can also do even more sophisticated things where you're polling other providers. Let's say you've got an English to Chinese translation service and you've got 5 competitors. You can actually go and poll their prices and then make sure that yours is always lower, right? And do interesting kinds of things like that. So once you actually talk about a machine economy, all of this machine decision making now becomes possible, and like dynamic prices are an enormous part of that, right? I think of dynamic pricing, this will be probably as important as like dynamic web pages, right? We don't even realize how big a deal this is going to be. So then the third big part of this is earning Bitcoin on every HTTP request, right? So we think of this as kind of a new way to monetize online. So once you've got some idea for some kind of machine payable application, we've got a centralized marketplace you can submit this to so that others can discover from it. You can run the 21 software on your own, but if you put it in the marketplace, then others can find it, and there's a lot of other interesting features like we have request and response filtering, stuff like that. One very important thing actually is if you list your app in the marketplace, then somebody can just open a payment channel at 21 and buy any other app in the marketplace. And that's actually one of the ways that in the medium to long term, you've reduced traffic on the blockchain and yet still support Bitcoin micropayments, right? So you set up one deposit and you have K APIs that you can call. So you can publish your apps to the marketplace, and you can also set up a profile over here. So here's Satoshi. He's got $2.10 and has basically got a bunch of different apps where he's making money, right? And so I think this is kind of cool. It's early days, but we think of this as sort of like the first social network where you're not making friends or adding followers, but making money, right? So like the first capitalist network, haha. We've got a community over here with actually more than 2,000 members. You can jump in and get your questions answered, and we have reasonably fast response on that if you jump in. It's a nice group of guys. So in summary, that's the 3 things that 21 does. It allows you to build this machine payable web, this third web, and the 3 things it does allows you to get Bitcoin on any device, add Bitcoin to any app, and earn Bitcoin on every HTTP request. Now, so you can get started at 21.co, and I can take some questions now, or I can just talk about the appendix sections, which Patrick asked me to talk about. So, Patrick, should I jump into the appendix? All right. Okay, good. All right. So I've got 2 supplements here, right? And the first supplement is basically just how do we think about this in a more macro context. So we really think what 21 is and what we hope it will be, especially over the next few years, is a way for developers to make passive income, and a piece of the vision in this really great book that's actually like Thiel's favorite book. It's one of Andreessen's favorite books, one of my favorite books, called Sovereign Individual, right? And there's actually a whole bunch of books that are like this, Seeing Like a State and so on, that I think of as sort of like a foundational library. It's part of 21 101. We'll hand these out at the front door, to new recruits. But let me talk about this book a little bit because I think it's important. So, back in the 90s, late 90s, there are a lot of things that people, sorry, the flash of the whiteness, yeah, I know. A lot of things that people talked about, right? So they talked about digital cash, and they talked about micropayments, and they talked about grid computing, and they talked about intelligent agents. And all of these kinds of things are now made possible once you have something like Bitcoin, and I think our software also helps with that, right? This is a tutorial you can see on our website. If you go to 21.co/learn, you can actually build an intelligent agent that will look for the lowest price, right? And so this basically, once you've got Bitcoin as this system resource, a lot of these things that people talked about become possible. In particular, one thing that becomes much easier than it was before is the ability to make passive income. So you can sit on the beach and you can have your machines making money for you. Right? You set it up right, and you just have your API service things, or you sit on the beach and you turn your lever, you pull your lever, and you're doing your mechanical Turk-like things, except it's a higher price mechanical Turk. Maybe you're a doctor and you're just diagnosing somebody next, and you get another Bitcoin payment, right? Anything that's information work, you can now start to unmoor it from location and allow people to just make money from anywhere. And that's really a big part of this book called The Sovereign Individual, which I like a lot. an entirely new realm of, the whole book is actually worth reading, and what I love about it is many books, you can take the entire book and compact it down to a paragraph, whereas this is the reverse. You can take a paragraph or even a sentence in this book and really expand it into like a full book or a full pitch deck. And what's cool about it is it was written in 1999, and it actually foresees a lot of the stuff that's happened over the last 16 years. What's interesting is about like half the stuff has come true already, and half of it are like just really good business ideas that you could go take and run with and develop. I would not be surprised if Satoshi read this book and developed Bitcoin, at least in part, on what's described in here, right? But there's one aspect of this in particular that I think is relevant, which is, an entirely new realm of economic activity that's not hostage to physical violence will emerge in cyberspace. The most obvious benefits will flow to the folks who are operating outside political boundaries. Incomes will become more unequal within jurisdictions and more equal between them, in the sense that everybody in the world gets an equal shot. And so when that happens, all these people, the billion people in China and India, the 300, 400 million people in Eastern Europe, Russia, in South America, and the Middle East, all these people who are kind of outside the world economy before are now coming online. And they're going to be competitive. And so, all these folks, you're going to have this thing where to be in the global middle class, you have to be at or above the global 50th percentile, right? And so the good thing about that is you've got global markets. The bad thing is you've got global competition. And we think that, when you've got a global digital currency and it's just easy to trade on the internet, just directly back and forth for Bitcoin without any intermediaries, that's going to be a big part of sort of bringing this vision about. Now, one thing that's sort of related to this, if you actually go back and look at the very, very beginning of Bitcoin, Bitcoin was actually built for a financial crash, right? You go to the very first block, and Satoshi talks about the chancellor and how there's another bailout in the UK, right? So timing is very hard to predict, and just like people have predicted a dot-com bubble for the last like 8 years, 9 years, people have predicted a financial crisis 2.0 for almost about that time, right? But suppose that does happen, right? Then an interesting question is what happens next, right? So if we go back and we look at the crash of 2008, what actually happened was that pre-existing trends gained new energy, right? So stuff that had already been around became more important. So the trial of 2008, when this financial crisis happened, stuff which existed like Y Combinator, like angel investing, like social media, it went from a growing niche that people in technology knew about to really the mainstream of technology today. And everybody thinks that, the way you're supposed to start is to go to an incubator, right? And that was definitely not mainstream 10 years ago, right? That was very niche. But it just gradually became this really big thing, especially after 2008, because people said, all right, there's not much money. What can I do with not much money, right? So capital costs went down, and that was an excuse to really go incubator style and start doing things with like 100K. I do think that the next crash is different because you're going to have issues with government legitimacy, and I think that Bitcoin is going to become a big part of what comes out of the next crash if and when it happens, right? So in the thought experiment that there actually is a crash of 2016, and it's not a thought experiment in China because they've actually already had this, right? In that thought experiment, what comes out of it? I think it's some combination of bootstrapping, hacker houses, digital nomadism, digital currency, and the developers of the developing world, right? And why do I name these trends in particular? Because hacker houses, where you have a bunch of folks living together, pretty common in San Francisco, pretty common in this area because of high prices. Digital nomadism combines with these because you find your hacker houses online, you move there. And all these folks, everybody's got a startup idea. Everybody's got a pitch, everybody's got something they want to build. And you start, basically just saving money by moving to low-cost locations. And these things mix together where digital currency is really at the core of it, where you're just trying to make money from anywhere, right? Crucially, these things all exist. Right? Like folks have talked about this stuff, just like YC existed before the crash of 2008, just like social media existed before the crash of 2008. These are pre-existing trends. They're not just going to come out of nowhere. But I think they're going to be amplified if and when a crash does occur, because these are things that reduce capital costs even further, from $100,000 in seed capital to zero, to the ability to just bootstrap to come up from nothing, right? So, C doesn't go away, VC doesn't go away. They just move up the ecosystem. And the new question is, what can you do at zero? Right? What can you do if you're just a kid with an Android phone, an internet connection, and maybe a little keyboard anywhere, right? And so, this is the kind of thing I think about a lot, which is sort of, taking a step back from where the ecosystem is today and seeing where it could be in, a couple of years. Now, we're not solving every piece of that, but we are tackling that digital currency piece and making it easier for smart people anywhere to make money, right? Okay, so now I'll give Appendix 2. So basically applications that you can build with 21. I know I'm jumping over a bunch of different things, throwing them fast. I'll send out the slide deck to the Slack channel. All right, so ready? Big bright flash is coming. Ready? Okay. Yeah, shades on. Yep. So in terms of the three class of applications that you can build with 21, right? There's one key distinction, right, which is what we call the cloud and the grid, right? So the cloud is like Amazon, where there's unidirectional payment, and you're renting servers over here, okay? The grid, by contrast, is bidirectional, where computers aren't just renting compute from others, they're also renting out their own compute, right? So you're not just buying from the grid, you're selling into the grid, okay? And so this is a bidirectional flow. The payment is on demand, right? It's not like on a monthly basis paying Amazon, right? And the nodes are all located around the world. They're not locked up in a single data center. So there's a different value proposition here. Now, importantly, by the way, these nodes are much flakier than the servers that are in an Amazon data center because you're on residential internet connections, right? So you might have 1/100th, or like from 99.9% uptime to like 90% or 99% uptime or what have you, right? So the uptime is going to be much worse here. But there's a lot of other advantages these things have, which is they're actually out in the physical world. Because they're out in the physical world, you can actually sense and actuate on the physical world for money in a way that you never could with cloud services, right? So the grid is like a fundamentally different thing from the cloud. And the distinctive properties, the fact that it's in the real world, you can sense and act upon, are things which we think drive some of the applications there. So I will skip over a quick history of the grid, but the main thing is that by putting 21 on any machine, you can like join the grid, right? You can buy and sell into it. Our marketplace facilitates this, but you can also directly connect to each other and rent grid services. I'll skip a little bit over the history, but let me talk about different kinds of applications just as motivation, right? If anybody does any of these in a good way, we'll give like $1,000 bounty in Bitcoin, just like as a fun kind of thing, okay? We'll post it more formally, but you guys seem like the kind of folks who'd be interested. So examples of grid computing tools, right? So you are a grid buyer, okay, what kinds of things would people sell into the grid, right? So one example we've already released is something we call Ping 21, where if you want to monitor the uptime of your website from many computers around the world, you can now go and pay them a little slice of Bitcoin and they can ping your website, right? And that's actually like a recurring thing because if you care about your uptime in, India and Brazil and South Africa and so on, well, you care about your uptime not just once, but over time, right? So you're constantly paying a little slice of Bitcoin for these machines to come and ping you and give you your uptime in those different countries or different locations. A related one is something we call Traceroute 21, and we've, I think, released some of the code for this. And this is something if you're Cisco, if you're Nicira, right, you want to know from a residential connection exactly how packets are being routed. So if you're debugging hardware of various kinds or you're trying to debug exactly how packets are flowing, often there's some DNS issue or something like that where this could be handy. Examples 3 and 4 are related to benchmarking, okay? So if you go and take a bunch of Amazon machines and have them go and try to stress test your website, you're going to get a very different result than if you rent 5,000 different computers around the world and have them stress test your website, right? They're just going to be qualitatively different. The Amazon machines, for example, will run into any cache based on an IP range. They're going to have a much better internet connection. They're going to have different latency characteristics. All types of stuff are going to be different, right? And so it's going to be a test that's very different from your prod, traffic. So JMeter21 and AB21 are based on the kind of Unix command line tools of the same name. JMeter is based on Java, AB is Apache Bench. And one of the things that we would do with this now, in theory, someone asks often, well, doesn't this mean that you can just do a DDoS of anybody, right? Can't you just rent 5,000 computers and point them at somebody and DDoS them on demand, right? So like the way to mitigate that is, this is sort of where like some of the marketplace features come in handy. In order to rent all those machines through the marketplace, we'd ask you to do a domain validation. So you show you have either an email address of the domain or DNS control, right? So this way we know that you can't just hit example.com unless you are John at example.com, right? Other examples, so spidering. Right, so a little known fact is it's actually very hard for Google to build something like Google today because robot.txt is everywhere and it's very hard to spider most websites. And many websites have only an exemption for Google and not for anybody else. So it's very hard to get that kind of content down. Now, there are services that will do spidering for you, but it is non-trivial to do. If you try to do it from an Amazon IP, you'll just find that that's blocked. right? They just don't allow spidering. So actually build a search engine, spidering is kind of a first-class problem, and guess what? You can, it's very cheap, rent a machine, boom, just send it off to Spider and get you back the content, right? Another example is if you're in China, right, you can set up a proxy server and just rent that for Bitcoin, okay? Here's another example. If you're developing something like a Skype, any kind of VoIP application, now you rent 2 nodes, like a node in Brazil and a node in India, okay? And now you can have them set up a VoIP channel to each other, and you can see the actual quality of service metrics on real users, right? And they're being compensated for that activity, right? So lots of stuff like this are what we think of as sort of grid computing tools, where once you can actually rent computers on the grid, their value is in the fact that they're not in a data center. Because let's say, again, you're testing that Skype example. If you took a data center, server in the East Coast and one in the West Coast, and you had them set up a VoIP connection, everything is going to work. It's all going to be fine, right? Because you just got this extremely high bandwidth connection. What you want is actually to try it on real computers, real machines, rather than kind of your test setting, right? Okay, so this is a class of like grid computing tools where you have like a Bitcoin Payable API in front of other machines, and it's kind of symmetric, right? But there's 2 other classes. The first are cloud computing tools, right, where you're going and wrapping things like a Google Maps or a Bing search or file conversion or what have you, and over here you're sending Bitcoin up, but on the back end you basically are just using standard API keys, right? Now why would you do this? Well, it just makes everything Bitcoin payable, Bitcoin composable. It's like a function, you can just do f of g of h of x, and once you've wrapped the API once, the labor's amortized across everybody else, right? So examples of this is a relatively risky one, but like server-side compilation, right? Send up a file, you have to really trust the server to send you back a binary that works, but if you do, that could, save you a lot of time. Lots of big companies run compile farms simply because, local compilation is an expensive process. Google Translate, Google Maps, file conversion, search, shapeshift like altcoin, transformation, or literally just putting any database up and paying on a per query basis are the kinds of things that you can do when you talk about like wrapping cloud services, with Bitcoin. And all these things are pretty easy to do with the 21, tools. You just put a payment required in front of the web service. The third and final class of applications you can build are what we think of as the crowd computing tools. And this is sort of like mechanical Turk type stuff, right? Where now on the back end, you don't have a cloud service, you don't have a machine service, you have human services of different kinds, right? So for example, you can pay people to SMS them. And we've got this demo on the website where rather than giving out your phone number, instead you give out a URL that people can pay you, and then you get an SMS out of your phone, right? So now your time is valuable and you can kind of rent that out, right? Or you can pay people to go and label training data. A little known fact is that the critical prerequisite for all deep learning, all machine learning, all AI is training data, and it's in short supply. And if you can just pay people directly for that, well, you can get a lot of labels. Now, there's ways to do this already with like Mechanical Turk. There's ways to do this like Google Training, like the reCAPTCHA stuff that you'll see on your logins. But this is like a systematic way that you can, fan out and do it. So this gives you a sense of the kinds of applications that you can develop with 21 on the grid, the cloud, and the crowd. I know I've covered a lot of ground here. Some of you guys, this old hat, some of you guys, it's all new. We'll paste this slide deck in our Slack channel so you can all get it, and Patrick will send it around. But let me stop there, and let me just take some questions, and let me make this less bright. Okay, great. Well, it's fresh in their mind, then we can do the fireside. Yeah, sure. Hi, yes? Can you hand him the microphone? Sorry, I can heard reputation, but not, sorry.
How are reputation metrics managed for nodes, like the quality of their service or uptime, responsiveness?
Good question. Yeah, so we actually, we do measure, we have a crawler that hits every endpoint that's listed in the marketplace, and we collect uptime, and we also have buyer and seller star ratings, but we're open to any other types of stuff on that. We think about that a lot. We also, if you have low uptime, we'll push you down in the rankings and so on.
Great presentation, thank you. So for the off-chain micropayment stuff, particularly the stuff where it's going through 21, how does how does KYC AML regulations relate to that? You can't really KYC a computer, but there's a person behind it. So how does 21 handle that?
Yeah, so basically there is, so I'm not sure how much I can talk about that, but I'll give it a little bit. So there is actually, so we've got a legal opinion, which basically is that the fact that we're reselling these APIs, and it's actually like a marketplace, there's actually an exemption under the MSB laws that allow marketplace activity, right? What we don't allow is any conversion of money. So you can't send in fiat and get Bitcoin out. But as pure Bitcoin to Bitcoin, where we're reselling a Bitcoin Payable API in a marketplace, there's actually an exemption under the MSB laws. But that's MSB. Now for KYC and AML, we do not allow OFAC countries, and we don't allow anybody on the watch list. So that's both country level filtering, so like Iran and North Korea and stuff like that, and also individual level. So if you sign up as Osama bin Laden, we won't be able to service you.
I got a question regarding your company. Where is your status? At some points you said that's happening in the near future and that works right now. How many customers have you, or transactions, or just pick a KPI and tell us more about that?
I don't want to talk about KPIs right now, but
that's surprising.
How much money do you have, right? Right? But I do believe give us about a couple of months and you'll see some big announcements. But we just open sourced this package, so try and have fun with that.
How did you first start to get interested in Bitcoin? And second question would be, what's your opinion on Open Bazaar and the future of the World Wide Web?
Okay, those are three big. The third one's a big question. So how did I get interested in Bitcoin? So in my previous company, which was a genomics company, I encountered the American regulatory state firsthand. I don't know if anybody was following personal genomics in 2010, but the FDA and Congress basically launched an investigation that essentially pushed everybody out of personal genomics other than 23andMe. That's why 6 years later, the industry is growing very rapidly, and that's why now 6 years later, most people don't have their genome sequenced, is 19 companies were driven out of business. And that made me understand the regulatory state in a very different way than, as an academic, career academic, I'd been up till age 28, and the worst thing the government could do is not give you a grant, right? So the worst thing it could do is not give you money. When you're on the other side of that, you realize that it's actually quite a different kettle of fish, and that sort of started my journey towards thinking about, okay, what is a regulation? It is a ban of a transaction between consenting individuals. Well, guess what Bitcoin is? If it wins, we globally unban transactions, right? So, that's our exit, right? Now, the crucial thing is, if folks actually like those regulations, now, if you take a second order view, there's a slightly, maybe arguably more mature view, which says people want a regulated marketplace in the sense that they want some actor, some leviathan, which is making sure that really poor sellers aren't in the marketplace, and B, kicking out malicious actors, right? Which are two different phenomena, right? The first is a 1-star seller, and the second is a 0-star seller, an actual crook, right? So they want a regulator where you buy from Amazon, you don't want to be scammed, you don't want to get a low quality thing, you want a leviathan. But I think the big thing that society hasn't yet adapted to is a recognition that, in the 20th century, the best way to build a leviathan like that was, a paper-based entity that corresponds to a nation state, right? So an FDA, an EPA, something like that. But today, it's these cloud-based things, so like eBay and PayPal, they all, or Gmail, right? All these things are effectively regulators of marketplaces, right? PayPal has fraud protection on both ends, and eBay has seller and buyer ratings, and Gmail has spam filtering and whatnot. And so these huge online, effectively marketplaces or communities, we've figured out ways to do regulation that aren't quite as heavy-handed. So I know that's a little bit of a digression. That's how I got into Bitcoin, because of regulation, and that's how I think about Bitcoin as a way to basically unban transactions, thereby cut through regulation. Now, your second question was on Open Bazaar. I love Open Bazaar, it's great. We're actually investors in it. I recommended them as a partner at Anderson in that meeting, and so thumbs up, and Brian is great. I think they're focused on a very different kind of use case, which is physical goods, and we're very much focused on APIs and digital stuff. Third question, future of the World Wide Web, it's too big for me, so I'll leave that one. Okay. Yep.
Do you mind talking a little bit about the MOOC you guys have planned for Stanford and maybe who the ideal audience for that is?
Yeah, sure. So we've sort of been working on this for a while in pieces. So there's a MOOC that I taught all the way back in 2013 that had like several 100,000 folks, and people seemed to enjoy that, and it was a lot of work. We've released a ton of documentation over the last about year with Bitcoin Payable APIs, which you can see at 20.co/learn. And a lot of that stuff is also at bitcoin.stanford.edu. If you want to sign up for the MOOC, go to bitcoin.stanford.edu and just put your name into that sign-up form. It's coming. It'll definitely come out there, just a matter of timing. Yep.
From a geographic perspective, where are people building things for the 21 marketplace and using the 21 network?
So we're in many different countries. I should actually get a number of different countries. But obviously we've got folks in the Bay Area, but we've got folks as far as Japan, India, Brazil, et cetera, all messing around with it. I think we're on every continent other than Antarctica, but that's 6 continents, right? So pretty distributed.
Hi. First of all, I have an owner of a 21 computer, and I had some minor failures, but your support is amazing, so kudos for that.
Okay.
And my question is, how much the mining itself is important to you, right? You are selling the devices, and I guess your big vision is perhaps there's a 21 chip in a MacBook or an iPhone and so on. So is the 21 pool the main business, or is it like, perhaps selling the 21 software for marketplaces to other people?
A good question. So I think that so the marginal cost of installing our chip into devices is very low, right? But it's not zero. Whereas if you think about our software, it is actually zero marginal cost to put it in a device, effectively, right? And as such, you can almost think of what our software is doing, especially this thing, the 21 cell. 21 cell is, in an interesting way, almost like virtualized mining in the following sense, right? If you put a 21 chip in a device, it is effectively selling hashes up to the network and getting Bitcoin down, right? So it's providing effectively a service up to the network that the rest of the network values, and you get Bitcoin down in return like a small stream, right? But the problems with that are that hardware, it can take time to update. It's basically like it's a very dumb piece of hardware, and it's like a machine minimum wage, right? If instead you have the 21 software on there and you're selling API calls up to the network and getting Bitcoin down, that's actually much more flexible, right? As time progresses, you can push an update, you can add more kinds of things, you can stay ahead of the curve, and you can add other kinds of things the machine can sell. Plus, it doesn't have the risk of a hardware installation, right? Now, with that said, a machine minimum wage is not a bad thing. It's like a default thing where you can always get a stream of it, right? So the way we look at it is our software, it's much easier to, you can see this, for example, coming up in Linux distributions. You can see this coming up in phone distributions and so on. So stay tuned for stuff like that. But the software is very easy to get installed in places. And then we think of that as something which, over time, builds a demand for large-scale hardware installations, right? So that's the thesis right now. We'll see what happens.
Hey, Balaji. Great presentation. Can I just ask a question? I'm echoing a bit. Just ask a question on something that's driving me a little bit crazy at the moment, which is how much are Bitcoin and Ethereum competitors and how much are they complementary? Certainly to me, it seems like whichever one is easiest to build conditional payments is going to win in an IoT space, but I'd just like to hear your thoughts on that.
Yeah, excellent question. So, so basically the question was Bitcoin versus Ethereum, to what extent is it a versus, to what extent is it an and so on, right? Okay, so let me give a long answer here. Is there any other kind? First is I'm pro Ethereum in the sense that, I respect Vitalik, and I think that what they've done is cool. I think we should watch it and play around with it, and I do play around with it, and we'll probably support it within 21 at some point. Okay, so it'll be one of the micropayment methods, right? With that said, how do I kind of see the respective roles shaping up? So at a minimum, the big thing about Ethereum, if you just take only one attribute of it, 17-second confirmation times and a commitment to scaling on-chain are really good, right? So that's like a 40x speed up versus a 10-minute average time. He said that he'll boost the block size if they get a lot of on-chain traffic, right? So those are good things. With that said, here is kind of 3 things that I think about Ethereum that are potential downsides, right? The first is it has just a much broader attack surface. So there's just lots of things you can do to mess up the Ethereum blockchain where I think as it starts to get closer to the Bitcoin blockchain, it was close. It was like 1 billion to 6 billion, and now Bitcoin has kind of pulled away with its own boost, and so we'll see what happens, right? But Ethereum was close as a percentage, and if it ever did become really close, I think you would see like a level of internet trollery and DDoSing that you've never seen before, right? Like all these crazy guys, folks, there'd just be this massive level of attack on Ethereum, right? Now, I'm not saying that's a good thing. I am saying, though, that Ethereum has a larger attack surface and Bitcoin is being more stress tested. That's like a conservative argument, but it's definitely something to keep in mind. The second is kind of more subtle, which is I'm not sure whether Ethereum can actually manage the transition to proof of stake. I call that a major open technical question, right? And for those of you who don't know the distinction here, so like proof of work is how mining works, where guys compete and they hash and they extend the blockchain that way, right? Proof of stake is something where effectively you have like a shareholder vote, where everybody votes effectively in proportion to how much Ethereum they have, and that determines where the next block is approved, right? The problem with this is with proof of work, you have like a fundamental like measure of how much computation went into the length of a chain, whereas with proof of stake, you only know how many votes were taken. And so you can imagine a situation where people do something in an attack called grinding, where you have a Hydra-like thing with lots of competing Ethereum blockchains. And you have to figure out which of them is actually the canonical one to follow, and then you have to introduce trust into the system, as opposed to the simple heuristic of just picking the longest chain with the most proof of work, right? So that is a fundamental difference between proof of work and proof of stake, which is an open technical question. Vitalik says he's got an answer for this, and he's a smart guy. So I have an open mind on this, right? But it's an unsolved problem in my mind, right? And the third question is kind of gets the most fundamental aspect, which is sort of the whys, right? And I tweeted this a few days ago, and I didn't mean it as like a diss or anything like that. One thing I think a lot about is it took Satoshi-level game theory to figure out how to do a decentralized wire transfer. Okay, like that's what Bitcoin is, a decentralized wire transfer. Now you don't even think about like a wire transfer as normally involving lots of actors and whatnot, but it does, right? Because the banking system is what you had to abstract and turn into this game theory around miners and all these different attacks, selfish mining and blah, blah, blah. This just 7 years of that crap that we basically managed to plow through and get to work, right? Okay, so if it took that to get a decentralized wire transfer, how much more challenging is it to decentralize a corporate charter? Okay, now, I've set up a lot of corporate charters. I've looked at lots of different ones. And I'll tell you that, like, for example, the Anderson Horowitz, charter, we know all our LPs, right? They are pretty conservative institutions. It's like pension funds and stuff like that. They all know each other. We all, like, eat food together or whatever, okay? Still, our charter runs to thousands of pages, anticipating all kinds of weird edge cases and stuff, right? Okay, and that's when you're talking about like humans who are somewhat bound reputationally by the fact that they're all LPs in the same fund or they're all investors in the same company or what have you, right? Now you replace all those humans or institutions, which are even more conservative, with the robots, right, that don't know each other, okay, that can launch automated attacks against a charter, that have no reputational constraints among each other, and can do weird kinds of things. I mean, like, I wouldn't even know what we would do if, say, like, Brown University said, hey, A16Z, we've got 150 Brown startups. You need to keep seeing another one each day and voting on it to see whether to invest our money and Harvard's money in that startup, right? Like, that's like kind of like the Dow, like if one LP just tried to keep voting to put its own companies effectively in front of you, right? Those are just kinds of attacks you don't even think about when you're doing like LP charters, right? And so like decentralizing corporate law, I think is going to be like at least 10 or 20 years. It's going to be something where it might be like AI. I saw a good tweet on this actually, and it was kind of like when we first developed computers, people thought, oh yeah, walking robots are just like right around the corner, But the hard part was the probabilities of autonomous control. When you start doing game theory on not like 2 people, but like 2,000 people in a company, that's like unsolved problem. And I think you're already starting to see that with the DAO. And that's not all of Ethereum, obviously, but it gets to a really core thing about Ethereum, which is that the programs, their difficulty may not be in the implementation, but they may be in the game theory and the human dynamics around them. So I think it'll take a lot of iteration for Ethereum to become useful beyond simply the fact that it's got 17-second block times and a commitment on-chain scaling. Okay, so that's a long answer, but maybe it's interesting.
Thanks for that. Can I just do a quick follow-up?
Yeah.
So on conditional payments, I mean, that's where I see where Ethereum and Bitcoin, if Ethereum succeeds, where Ethereum and Bitcoin are going to be fighting in the conditional payment space.
Can you elaborate what you mean by conditional payments?
So this is where, so you've got machine-to-machine payments.
Yep.
This is where you write a contract such that funds are released in future dependent on a future event, right? And so that's really easy to do on Ethereum and much tougher on Bitcoin. So, I mean, it's a very big assumption, but just to assume that Ethereum does succeed on its many challenges, on that conditional payment space, do you think Bitcoin can replicate what you can do on Ethereum?
Yes, because, this is our thesis, let's see if it's true. I think actually the answer for the next few years is centralize everything other than Bitcoin itself. And here's why I say that. Given that example of conditional payments, you need an oracle, right? You need some external party. What is the weather at this time to pay off this bet, right? What is the score of the Warriors game to pay off this bet, right? And there has to be trust in the system, right? So like Bitcoin, after enormous effort, we got to this point that the thing functions, right? Like despite all these attacks on it, it functions. And simply taking Bitcoin and baking micropayments into the top 500 web apps is like a 10-year task, which will cause hundreds of like billion-dollar companies, right? I mean, the way I sort of think about it is, you can take Bitcoin and you can go in a few different directions with it, right? One direction is you do more science. Okay, that's Ethereum, right? Ethereum has legitimately innovated on the science of distributed state, right? What I mean by that is Bitcoin is distributed state because you're doing a minus here for this guy's balance and a plus here for this guy's, and you're propagating that out to a lot of nodes, right? So that's distributed state in the simplest way. A payment is a minus here and a plus there, and you replicate it, right? Ethereum lets you do much more sophisticated things, not just a minus and a plus, but like all kinds of complicated stuff, right? So it's improved on the science. However, to every update of that thing, it's fast relative to Bitcoin, but it is it's 40 seconds, or it's 17 seconds. And it costs money every time you're updating that database, right? So outside of payments, you have to have a really, really good reason to do something in distributed state in order to push something in distributed state, right? So that's kind of number one. The alternative direction that we're taking is not to improve on the science, but on the engineering, right? Say, look, Bitcoin works. Let's make it a first-class citizen in a Linux environment, okay? Let's make it work with Linux and HTTP and Python, right? Let's make it work with Rails, and let's make it work with every major web framework, and let's make it installed in every Linux distribution, and let's make it something where you just don't even have to think about it, and it's just part of the background as a programming tool, right? And so now you don't, when you do payment required over here, like we've actually abstracted out so much for you so that you can just get started with micropayments, right? And so all the other stuff is stuff people already know about and they already know how to use, and they don't need to learn new concepts. They just say, hey, what if I could price things dynamically? What can I do with that? There's a lot you can do with that. And that's at least our thesis, right? And we'll see which one is right.
So how do you envision 21 getting out there in the hands of the masses? Because obviously a lot of the success of some of the ideas depend on massive amount of 21 nodes. So that's one question. And the second is a lot of the ideas that you talked about really are sort of pointing towards, they're really going to support a decentralized web. I mean, we had our first decentralized web summit last week. So do you have that in the roadmap, 21 somehow supporting a decentralized web?
Yeah, so basically within about a month and a half, I think maybe maximum 2 months, we're going to launch something which I think all you guys will actually find very useful. And I'll dangle it like that. But basically all the tool stuff that we have built is all leading up to something. And so, we've got all your emails, so, we'll ping you. So that's the first answer is we have a plan for how to basically equip you guys with, call it free Bitcoin, but you're doing something for it, but you won't find what you're doing very onerous. And that will be, I think, the channel for writing a lot of these programs. Now, over time, how do you get to a decentralized web? I think that's an enormous undertaking that takes a long time, and it's going to take more than us, which is part of why we open source this. But I do think that there's things that pull us in that direction. And one of the things that pulls us in that direction is, is this. like the phone, right? Because these are getting more and more powerful, and you're going to have more and more data stored locally, right? In which case you'd sort of invert the typical social network application. Rather than having a centralized data store, you'd have a cache, and then you make requests to people for the latest version of their information, right? So rather than LinkedIn and Facebook and so on all having a copy of your name, they would make an authenticated request to you to pull that information. I think that is a very long term as to where we're going. At A6Z, we've got a thesis on this. We call it like the billion phones is the next data center. But we need to figure out the monetization step, and we're like hopefully a small piece of that.
Thanks as always. Thanks as always for a wonderful presentation. My question actually dovetails a bit from what we were speaking earlier about big, sluggish corporate folks, and you were at Consensus. What is your impression of their approach to this entire suite of technology, and how people, especially in the sort of financial world, are looking at this stuff? Because, I mean, it seems like from my perspective, there's a pretty huge gap.
Yeah, good question. So like private blockchain, right? So again, sort of like Ethereum, I'm pro private blockchain in the following sense. I'm very happy that lots of banks are thinking about this stuff, right? I'm happy that they're actually going to be employing a lot of people with Bitcoin expertise. That's actually very important. I mean, that's a whole new large quantity of money that's come in, which is basically hiring anybody who has any like Bitcoin programming expertise on their resume. So all kinds of Bitcoin startups and so on are getting folded into these large banks. And you know what? Like acquisition's an acquisition, or a payday's a payday. So that's good, right? And finally, I'm glad that you're getting guys who are from like the Bitcoin ecosystem going and giving presentations like, for example, my friend Adam Ludwin at Chain was recently at the Federal Reserve and talking to like 90 central bankers about, Bitcoin and blockchain, right? Like, that's awesome. So all that stuff is to the good, right? Okay, so now given the gap and stuff that you're talking about, there's actually a pretty good PDF that came out from, I think it was like either Bank of America or Merrill recently on like, it was like a 34-page thing that basically said, what I think I tweeted this in like March, which is that private blockchain and Ethereum were sort of at the top of the Gartner hype cycle in like March, and Bitcoin was kind of at the bottom. And now it's kind of going like this, where they're going into their troughs, and then I think Bitcoin is coming up, right? And the reason so we already talked about Ethereum, like the DAO and stuff. I think there's going to be all types of shit associated with that. But with private blockchain, I think the issues are going to be more organizational, right? When you're talking about sales, right, and actually getting an organization to install something and run it, at A6Z we have this saying, which is that getting an enterprise sale is like getting a bill through Congress, right? Because it's not just about the merits of it, it's about the politics of it, and you have to get the CIO to sign off, and he doesn't like the COO's cut of his jib, and this guy, like, whatever. There's all this internal politics within a company, right? So if that's like getting a bill through Congress, well, a blockchain sale, a private blockchain sale is to a consortium, right? Because you've got a bunch of different economic actors that are all updating this blockchain. At least that is the most common application of it. And in that case, well, now you're not talking about selling one actor on a database. You're talking about selling N actors on a shared database, which is more like not a tree, not a bill through Congress, but like an international treaty, right? You've got to get all these guys who are at war with each other to agree on this private blockchain as the way that they're going to be doing things, right? And that's hard. And what's also hard is to make money while doing that, because that's like the guy in the center doesn't have leverage. It's a so-called oligopsony environment, right? Monopsony is monopoly buyer, like the U.S. Department of Defense is a monopoly buyer of F-16s, right, or close to. In this case, you'd have oligopsony, where the consortium are the only buyers, effectively, of this blockchain product, so they have enormous pricing leverage with the guy, right? So with that said, I think that the best opportunities for private blockchain are going to be kind of the things that, again, my friends at like Chain are doing. So like with NASDAQ, right? NASDAQ already has a whole platform set up, and if they just swap in blockchain there, maybe there's something they can do with like opening up the NASDAQ API, for example, right? So stuff like that, I think, is going to be the first applications of this, but it's going to be much harder than people have thought. Yep. Get that guy, I think, or somebody who hasn't answered a question yet. Well. Anybody didn't?
Both have, I think.
Yes, okay.
Coming back to what you said about a single buyer of a blockchain like NASDAQ, Why does he need distributed then, if he's a single buyer?
Well, because there's a lot of guys who use the NASDAQ who, so I'll give two answers to that, right? The first answer is, if nothing else, just like if nothing else, Ethereum is 17-second block times. If nothing else, private blockchain is an excuse for doing long overdue enterprise IT and banks, right? So like 40 years of Cruft and COBOL stuff gets thrown out and they have new like Rails and Django and Node apps, right? And that alone is like a win, right? So that's like part one of the answer there is, well, guess what? They now have a CEO level imperative to go and rip out these old systems and replace them with new stuff. And that alone will give them a huge part of the benefit, right? So that's the first answer. The second answer, so just like the hype of the blockchain word allows them to just bunker bust this legacy code out of there, right? The second part of the answer is I think that there are interesting cases where the rights to the blockchain may be centralized, but it might be more replicated than normal. So for example, NASDAQ may make it possible to download a database of all of their trades, right? And so even though NASDAQ is a trusted party that updates it, nevertheless, it's like a more transparent thing where you can actually just download a massive gig file that is the history of every trade ever made and all the shares and how they are going through, right? And that would actually be a really useful data structure because I don't think they track chain of custody quite like that, right? So I think there's applications for it that are not just pure decentralized, but some hybrids like that.
So it's still very early for 21, but are you concerned in the longer term about the block size debate and making various business models around micropayments just not viable if there is a core dev team who are intent on pushing up transaction fees?
Right. So we've been, studiously Switzerland on that, in public. So I guess my quick answer on that is we have kind of a defense in depth or kind of multiple, fold approach. So the first is something I mentioned, but that we'll have a blog post out on, which is if you open a micropayment channel to 21, then you can buy from anybody else who's connected to 21, right? So it's like a hub and spoke model that facilitates it, right? And that becomes more useful, obviously, the more nodes that are collected, but it's at least one way to work around, right? The second is, if push comes to shove, we can always implement Ethereum support as a second, safety valve. And the third is, I do hear rumblings that, like maybe that 2MB, hard fork will go through at some point, right? With that said, we'll see what happens, and we will continue to do our thing, regardless. Good. Why don't we take a break, get some food, and then do a fireside chat? Sound good? All right, great. Thanks.